Okay, pause and copy. Pause and copy. All right, so what are we doing here? Getting some new tools here. Kramer's rule, theorem 7, gives us a formula that is generally not efficient. However, let's say I want to solve this system and I only want to find, say, x3. Okay, in that case, I think it's actually pretty efficient if you just care about finding one of these x values. Otherwise, it's better just to row reduce. Again, then we're going to use Kramer's rule to get a new formula for A inverse, which is occasionally useful. Okay, so Kramer's rule is mainly this formula here, where I have defined this matrix, but I think an example would be best to illustrate how this works. Okay, so I'm going to use Kramer's rule to solve this one. So pause and copy this. So what does Kramer's rule say? It says that I can find x1 by doing a1 b, determinant of a1b divided by determinant of a. And then let's see, x2 would be determinant of a2b all over determinant of a. Okay, so I'm using this formula here for I equals 1 and then for I equals 2. Okay, so looking at these things, I have three things to find. I want to find this determinant, and the determinant of A. So why don't I start by saying what A is? Why don't I do that over here? Okay, so from the system, I can extract A quickly, 5, 7, 2, 4. And so the determinant of A is 20 minus 14, which is 6. Now A1, B. Okay, B should have an arrow on top, but it's kind of awkward to draw. There we go, I got it. Now what is A1B? Okay, what you do is you start with A, and then you're going to erase the first column, because there's a 1 here, and plug in your B instead. Okay, so my determinant of this thing is 12 minus 7, 5. And then A2B is, you start with A, and then you replace the second column with B. So my determinant that I need is 5 minus 6 minus 1. Okay, so I have the three items I need. I can just plug them in over here. X1 is 5 over 6. And X2 is the negative 1 over 6. Okay, you can verify that this is actually correct. If you want to see a proof of Kramer's rule, that's of course available in 3.3. I think it's kind of technical, so it's the kind of thing you want to read and kind of stare at and think about. But I'd be glad to help you through any snags if you do choose to read it. Okay, let's try an exercise. Uh, Same question, but here's my system. 3x1 minus 2x2 equals 6 minus 5x1 plus 4x2 is equal to 8. Okay, so pause, copy, and try this using Cramer's rule. Pause, copy, try, pause, copy, try. And the answer is x1 is 20. X2 is 27. Okay. So basically you have B is here, A is given over here, and then you just use your formulas, use your Cramer's rule formula to sort things out. Okay, now the new formula for the inverse. So the inverse actually can be calculated. I just use the notation I usually use. Okay, so the inverse can be written as 1 over the determinant times this matrix here, which is called the adjugate of A. So what is that? Oh, let's show you where the adjugate of A, adjugate, spell that, adjugate of A. So what we're going to do here is we are going to use our cofactors, Cij. So what is Cij? Cij is -1 I plus j times this smaller determinant, right? So we're going to use that to define our adjugate. So what you do is you take this matrix that's actually filled with the adjugates, so C11, C12, C1n. Let's say that A is square, of course, n by n. So you're going to fill this matrix with the cofactors in the obvious way. C, N, N. Okay, this is called our cofactor matrix. And then there's one wrinkle. You have to transpose it, unfortunately. You have to transpose this cofactor matrix. Okay, so what I'm going to be doing is calculating a whole bunch of cofactors, putting them into a matrix, and then finally transposing it. That's what I will put here. And then I'll stick a 1 over the determinant in front. Okay, let us try some examples to illuminate. So I'll invert this guy here, 0 minus 2. Minus 1. 3, 0, 0. Negative 1, 1, 1. Okay, so what am I going to have to do here? I'm going to have to find a whole bunch of cofactors here. So how should I go about that? Yeah, I guess the first time you have to just kind of grind it out. So you say C11 is negative 1 to the 1 plus 1. I'm using this formula up here, right? Times some determinant. Which determinant? Well, it's the determinant you obtain when you delete this column and this row. So first column, first row. That's the 1, 1. Okay. So what do you get? You get 0, 0, 1, 1. So this one just turns out to be 0. C12 is negative 1 to the 1 plus 2. And then you take, you delete first row, second column, and you get 3, 0, negative 1, 1. So what's that? Negative 1 times 3 is minus 3. And I continue in this way. C13 is negative 1, 1 plus 3. First row, third column. First row, third column. 3, 0, negative 1, 1. So that's going to be plus 3, right? Okay, so with practice, you can do this basically mentally, For example, if I want to find C23, okay, mentally you can go second row, third column. The determinant is negative 2. And then 2 plus 3 is odd, right? So you have a negative 1. Okay, so with practice, you can do that mentally. You can do that mentally. You can find all these cofactors mentally. So I get negative 1. So for C21, second row, first column, negative 2 plus 1. 1. So I'll try to do these mentally and not make too many mistakes. 2, 2, 0. I already got C23, C31. Plus 1. Third row, first column, 0. C32. 3 plus 2 is odd. Third row, second column. Third row, second column. 3. Finally, C33. Plus 1. And third row, third column. 0 minus negative 6 is plus 6. Giving me 6. Okay. Now, for my formula, which I think I will prove later, I need all these cofactors, but I also need the determinant of A. So why don't I take a second and do that now? Determinant of A. I want to use second row, right? So I get, let's see, minus 3 times the determinant remaining, which is negative 2 plus 1. Oh, which is, it's actually one of these cofactors over here, isn't it? Oh, well. So we got 3. So A inverse is, what is it again? Oh, yes, this 1 over this determinant, and then the adjugate of A. So it's 1 over 3. Now the adjugate is going to be something transposed. Don't forget the transpose. And I'm going to take all the numbers I found over here and just put them in. C11, C12, C13, C3, oops, C21, just 1, C22, negative 1, C23, 2, C31, 0, C32, minus 3, C33, 6. Okay, let me just double check. I haven't screwed up there. 0, 0, 3, and then 3, 2, 6. Looks good. Okay, so just perform the transpose, and Bob is your uncle. All right. So, exercise. Same question, but now A is going to be 2, 1, 3, 1, negative 1, 1, 1, 4, negative 2. Okay, pause, copy, try to find the inverse using the formula given here. Pause, copy, try. And when we come back, I will reveal the answer.